Okay, in the last problem of the homework on black holes, we're dealing with this idea of gravitational redshift, which is a very challenging idea to really understand. But there is a formula for it that allows us to calculate how the time elapsed near a black hole is different from the time elapsed far away from the black hole. And in this case, we're standing 1.01 times the Schwarzschild radius away from the black hole. There was a similar example in the PowerPoint for this week, the lunch by a black hole example, but it was a different distance away. You were at 1.1 times the Schwarzschild radius, and this is 1.01 times the Schwarzschild radius, so we're a little bit closer. All right, so how do we solve a problem like this? Let's look at this formula in a little bit more detail. On the left, this t is the time as measured by an observer near the black hole. So this is the time on their watch as they sit near the black hole. That's how much time they experience. This time is the time as measured by an observer that's far away. That's what the infinity means. They're just infinitely far away. So the idea is they're not affected by the gravity of the black hole. So this is like what we would say is Earth time, like far away from where the black hole is. And then there's this square root term. RS is the Schwarzschild radius of the black hole. So that's like where the event horizon is. Inside the event horizon, light cannot escape. So this is a property of the black hole. And then R is the radius of this observer. Okay, that's where this person is in relation to the black hole. Now notice in this formula that if R is equal to RS, this is 1. 1 minus 1 is 0. And you have this time gets multiplied by 0. So this time is 0. So no time elapses for this observer when you are at the radius, the Schwarzschild radius. If this number was less than the Schwarzschild radius, then this number is bigger than 1, and you're subtracting a number bigger than 1 and trying to take its square root. You can't do that. You can't take the square root of a negative number. So this only makes sense as long as you're outside the radius of the black hole. And then we can think about, well, what happens as you get further away or closer to the Schwarzschild radius? And so I plotted this out in a tool that I like to use called Desmos. Let me bring it down here. Okay, so this is called the Desmos graphing calculator. It's a free tool. It works just like a graphing calculator. And I plotted this function. And so you have to call it the y variable. The y variable is the time that someone experiences back here on Earth or far away from the black hole. And one would be like 1 hour of time near the black hole. So this is to kind of get an idea of what happens as you get closer to it. So when you're far away, let me bring it up a little bit more. When you're far away from the black hole, the time is just normal. 1 hour is 1 hour. So this would be 1 hour. But as you get closer and closer to the black hole, the time gets more and more dilated. And in fact, it becomes infinitely dilated at the radius of the black hole. So this would be 1 Schwarzschild radius away, 2 Schwarzschild radiuses away, 4, 6, 8, so on. Okay, back to the equation for a second. So what I plotted there is this, which is this equation rearranged. So I solved it for t infinity, the time measured by the observer far away, which in the homework problem and in the problem in the PowerPoint, that's what you're solving for. You're solving for this one, which means you take this time and divide by whatever this number is. So the question is, what is this number, this square root term? And in the problem, in both of the problem in the homework and in the example in the PowerPoint, you're given the radius of the observer as some multiple of the Schwarzschild radius. And the reason is or the reason why I did them like that, is because it actually makes it easier. You don't need to know what this number is because it will cancel out. So if I have RS here and I have any number times RS here, then the RS's cancel out and I just have 1 over whatever that multiple is. Okay, and so back to the calculator tool. If I have 1 hour of time near the black hole, this is how you calculate what the time is far away. How much time will have elapsed for someone far away. This is always a 1. This will be a 1. And this will be whatever multiplies the Schwarzschild radius. So in the example on the PowerPoint, it was 1.1. Okay, I could put any number here. So if I'm twice the Schwarzschild radius away, this would be a 2. And time would be multiplied by 1.4. So it would be 1.4 hours on Earth. If I got really, really close to the black hole, so I was almost at the black hole, so it was a 1.00001, then the time would be multiplied by 3,000 or so, right? So every hour you spent that close to the black hole would be 3,000 hours in the Earth time. All right, and so any number, whatever is multiplied by RS would go here. So it's 1 divided by the square root of 1 minus 1 over whatever that number is. That's what you're ultimately trying to calculate in these types of problems. And the smaller this number is, or the closer it is to 1, the bigger this number is going to be.